3.1 goes over your quadratic functions and different ways that you're going to see these quadratic functions. You're going to see these in ways that we call standard form and vertex form. Your first equation that you see here, that f of x is equal to ax squared plus bx plus c, we're going to call that standard form. Okay? You can use your a, your b, and your c in order to find different parts of these quadratic functions. We're going to be looking at the vertex, the axis of symmetry, your domain and range, your x and y intercepts, whether or not you have a maximum or minimum, and what that maximum or minimum is. Again, your standard form is just f of x is equal to ax squared plus bx plus c. These are formulas that are representing functions that are parabolas, so they look like a U. Those parabolas will either open up or down. If a is positive, that parabola is going to open up. If a is negative, the parabola will open down. So just something to keep in mind. You will also see this formula that you're given in something called vertex form. Your textbooks likes to call it standard form, but we're going to be calling it vertex form. Your vertex form is in the form of f of x is equal to a times x minus h squared plus k, where your a is the term that tells you whether or not your parabola is opening up or down. The h is the x value from your vertex, and the k is your y value from your vertex. Your vertex is the ordered pair that is either the highest or lowest point on your parabola. If your parabola opens up, that vertex will be your lowest point. If your parabola opens down, that vertex will be your highest point. And if your formula is given to you in vertex form, it's easy. You just pull out your h, you pull out your k, and you plug those into x and y in an ordered pair, and that gives you your vertex. If you realize this formula that you have, that f of x is equal to a times x minus h squared plus k, the h has a negative in front of it. So it's just like your transformations when you're going right and left. Think the same thing. Take the opposite of that number. So if it has a negative in front of it, that h is going to be positive. And vice versa. If it has a positive in front of it, that h is negative. For your maximum and your minimum values, again, it's coming from your vertex. If your parabola opens down, if your parabola opens up, you're going to have a minimum value. The y value, your k, is going to be the minimum. If your parabola opens down, that means you have a maximum point. The y value from that vertex is the maximum. So your y value from your vertex is what you're getting for these max and min points. If the parabola opens up, again, the lowest point you have, that means you have a minimum. So the y value comes from your vertex, and that's your minimum. If your parabola opens down, highest point is going to be your vertex. And then from there, you pull out your y. That's your maximum. You can use these two formulas for h and k if you need to. So if you're given an equation or a function in standard form, that f of x is equal to ax squared plus bx plus c, you can identify your a, your b, and your c, and use b and a to find your h, and all three to find your k. To find your h, you can use negative b over 2 times a. To find your k, you can use c minus b squared over 4 times a. This is for your vertex. Your axis of symmetry is something that's not within your written notes here, so it might be something that you want to write down. Your axis of symmetry is the x value at which an invisible line cuts that parabola down the center. So it cuts it in half down the center. So your axis of symmetry, just write this down if you can. Axis of symmetry. It's a lot of times represented by AOS. Is the line, the invisible line, x is equal to line that cuts, oops, the parabola in half. Okay, so if you're looking at a parabola that opens up, that axis of symmetry is literally going to be the invisible line that cuts the parabola in half. So whatever the x value is from your vertex is what your axis of symmetry is. So it's just x is equal to that h value. Okay. If we look at some examples, this first one here is also the same example that you see like within your notes within like the first 3 pages. So it's the same exact one. We're given f of x is equal to 2x squared minus 12x plus 23. We're finding the domain, the range, the vertex, the axis of symmetry, whether or not it has a maximum or minimum value and what that value is, as well as the y-intercept and the x-intercept. First thing that you should be doing with these is identifying your A, your B, and your C, especially if it's not in vertex form. What is your A from this? You have 2x squared minus 12x plus 23. What is your A? Good. What's your B? And what's your C? Don't worry about your domain and range yet. Find your vertex. Your vertex, we said to find h, we can use what? And to find k, we can do?
C minus b squared over 4.
Good. So we're going to use these to find your h and your k. To find your h, we said b is what? So we're taking the opposite of negative 12 over 2 times a, which is 2. The opposite of negative 12 is positive 12. The 2 times 2 is 4. And 12 over 4 gives us an h of what? 3. To find k, you have c minus b squared over 4 times a. What is c? 23 minus b squared, so that's going to be negative 12 squared over 4 times a, which is 2. In that fraction, that negative 12 squared is 144 over 4 times 2 is, does that 144 over 8 simplify? They're both even numbers, right? So at least divide them both by 2. That gives you 23 minus what? 144 divided by 2 is 72 over 8 divided by 2. To 72 over 4 simplify. To what? So k is equal to 23 minus 18. What is 23 minus 18? 5. So you have an h of 3, a k of 5. Your vertex is the ordered pair h, comma k. So that gives us what? 3, comma 5. So your vertex here is the ordered pair 3, 5. Your axis of symmetry comes from your vertex. It's the x value. What is your x in this axis of symmetry? 3. So your axis of symmetry is x is equal to 3. Again, the vertical line that cuts your parabola in half is your axis of symmetry. Next, find your maximum or minimum value. What is your A? 2. Is 2 positive or negative? Positive. So this parabola is going to open up. If this parabola opens up, do you have a maximum or a minimum point? A minimum point. That lowest point is going to be a minimum point. If you have a minimum point, what is the y value from your vertex? So your min or your minimum is 5. From here, domain and range, you have a parabola. If this parabola was on your graph, let's do it this way. If you had a coordinate plane, let's say this is your coordinate plane, and this is the ordered pair 3, 5, that is your vertex. Give it a second. There you go. From that ordered pair of that 3, 5, you are looking at that parabola, and that parabola opens up. Are you going to have any points cross over that x-axis? No. So keep that in mind while you're doing this. If you're finding your domain, your x values, what are your x values that are being covered by that graph? All of them. So from negative infinity to positive infinity. What about the y values that are covered by that graph, that line? From positive 5 to positive infinity. Does it include that 5? Yes. So what goes on the 5? A parentheses or a bracket? Bracket. So we're going 5 to infinity with your bracket on the 5. So the last thing you have to find with this are your x and y intercepts. If you have that parabola on your coordinate plane, we said that that parabola is never going to cross over the x-axis. So are you going to have any x-intercepts?
No.
No. So you can just write none for those. The y-intercept, what's your c value from the original 23? So your y-intercept is always 0, comma something, so that's going to be 0, comma 23. The next example that we're going to look at, we're going to work with f of x is equal to negative x squared plus x plus 2. What's your a term from here? A is negative 1. What's your b?
1.
And c? So now that we've gotten c, what's your y-intercept? 0, 2. Okay. Your a is negative 1. It is negative, which means it opens down. So you're going to have a parabola that looks similar to this. If it opens down, do you have a maximum or a minimum? Maximum. Now, find the vertex. We said to find x, we can use what? Negative b over 2a. That's also your h. Is that better? Then you also have to find k, which is your y, which is c minus b squared over 4a. Good. Okay. So you have your a, your b, and your c. Plug them in. Simplify. To find h, the opposite of b is going to be the opposite of 1 over 2 times a is 2 times negative 1. The opposite of 1 is negative 1. 2 times negative 1 is negative 2. Negative 1 over negative 2 gives you an h of 1/2. Your k, you're going to find that by using your c minus b squared over 4 times a. We said c was minus b squared is going to be 1 squared over 4 times a is negative 1. So from here, this is going to give us k is equal to 2 minus 1 over negative 4. Those two negatives turn into positives. So k is equal to 2 plus 1/4. If you want to turn this into an improper fraction, it would be 8 over 4 plus 1 over 4, which is just 9 over 4. So your vertex is the ordered pair h comma k. What's your vertex? 1/2 comma 9/4. Now that you have your vertex, what is your maximum point? Or what is your maximum value? Remember, your maximum is the y value from the vertex. So it would be the 9/4. Your axis of symmetry is the x value from your vertex. What is x equal to? 1/2. So your axis of symmetry is x is equal to 1/2. What's your y-intercept? Or sorry, your x-intercept. We already have your y-intercept. What's your x-intercept? It's not none. This one, if you can factor what you have, set your f of x to be equal to y, which is also 0 in your x-intercept, and factor it. So if you're going to take 0 is equal to negative x squared plus x plus 2, solve for x. What's your greatest common factor that you can factor out in order to make that x squared a positive? So factor out a negative 1. That 0 is equal to negative 1 times x squared minus x minus 2. Well, your factors of negative 2, that add up to be negative 1. 1 and negative 2 give you negative 1 when you combine them. So that's x plus 1 times x minus 2. Set all three parts of this, since it's factored completely, equal to 0. So you have 0 is equal to negative 1, 0 is equal to x plus 1, and 0 is equal to x minus 2. Solve for x. The 0 is equal to negative 1, false statement. Get rid of it. Forget about it. Don't work with it. It's not true. So there's no x in there, so there's no way to solve for x for that one. For the x plus 1 is equal to 0, subtract your 1 over. You have that x is equal to negative 1. What ordered pair does that give you for your x-intercept? Negative 1, 0. For x minus 2 is equal to 0. Add your 2 over. That's going to give you x is equal to 2. So the ordered pair for your x-intercept for that one is 2, 0. So you have two x-intercepts here. One that's negative 1, 0. The other that's 2, 0.
Mm-hmm. If instead of factoring out negative 1, you like factor out an x, because 0 equals x. So
you can't factor out an x with that because that 2 doesn't have an x on it.
I remember saying like if you could, like, and there was
And then yes, then you would have 0 as an x-intercept as well. Okay. What's your domain? Negative infinity to positive infinity. It covers every x value. What's your range? Look at your vertex and look to see if you have a maximum or minimum. You have a maximum, so it goes to negative infinity. What's the highest value you go to? 9/4. So your range is going from 9/4 to positive infinity. So instead of it going from negative infinity, we're going to from positive infinity, we're going to negative infinity. So this should be switched to where it goes from negative infinity up to 9/4, including the 9/4. So that's the correct range.
Are there going to be any on the test?
It could be.
I mean, like
It could be both. Yeah, it's going to give it to you in both. So the other two examples that you have, we're going to look at this one first. We have f of x is equal to negative 3 times x plus 4 squared minus 9. We're going to pull out the vertex, the axis of symmetry, your maximum and your minimum, or your maximum or minimum, so your domain and your range. Look at your formula. In vertex form, it's f of x is equal to a times x minus h squared plus k. So what can you pull out from this formula? The negative 3 is your a. Your h is your negative 4. Think opposite of the sign in front of it. It's supposed to be negative. It becomes positive. So it would have to be a negative 4 for your h. Then your k is your negative 9. Your vertex is the ordered pair h comma k, which in this case is your negative 4, negative 9. The axis of symmetry is the x value from your vertex, so that's just x is equal to negative 4. Your maximum or minimum is told by the a value. Your a is negative, so that parabola opens down, which means you have a maximum. What is the maximum? What's your y value from your vertex? Negative 9. Your domain, it's a parabola, so automatically negative infinity to positive infinity. Your range, your y values that are covered, it opens down. So you're going to go from 1 point to negative infinity. What's the highest point that you have? the -9. So it's just from -infinity to -9 for your range. This is why I was saying, once it's in vertex form, it's a lot easier to pull out all of this information because it's literally giving you your h and your k. There's really no math or plugging in to find h and k. For your last one, you have f of x is equal to 1/2 times x minus 7 squared plus 1. Again, this is in the form of f of x is equal to a times x minus h squared plus k. What's your a? What's your h? Positive 7. What's your k? Okay. What's your vertex? 7, 1. What's your axis of symmetry? Maximum or minimum? Minimum. It's a positive a, so it opens up. You're going to have a minimum point. What is that minimum point? Just 1. Your domain, automatically, all real numbers. Your range, remember, this opens up. That vertex is the lowest point, which is 7, 1. So we're going to what? We're going to infinity. What's our lowest y value? 1. So it's just 1 with a bracket on it to infinity.